This is a very common application whereby the intent is to detect whether date code or lot code has been applied onto the cans or not. Since the cans have got a very shiny metallic background, the ideal lighting to be used over here is a dome lighting. So whether it's an i10, i20 or an i40, the dome accessory should be used in conjunction with that to produce a uniform lighting and an image that's similar to the one that's seen on the screen. The inspector cannot read the quality or determine if the quality of the code is good or bad. It cannot do the character recognition or read the numbers that are on the can, but what it can do is tell you whether the code has been printed or not on the can. The approach would be, you would just teach the reference object, and what it does is it takes the object from the image from the live image and puts it in a reference image tab, and it puts an object locator around it. We will not be using an object locator, which is our pattern match tool, because the cans are assumed to be presented very reliably every time. So ideally you would want to do this inspection immediately after the code has been put on the can and make sure that the presentation of the parts is very reliable. What you would use is you would use a pixel counter tool. So you would basically, since the expectation is that the code is always going to be in the middle of the field of view over here, you would create your region of interest somewhere on the center, and then that basically the settings for the tool appear on the right hand side of the screen, and you can rename this to anything you want. And then you would have to adjust the intensity. So if I go and adjust the intensity from 0 to 255, that would highlight or select the entire region of interest, but I only want to detect what is darker in this field of view, so I would get rid of whatever is bright, something along those lines. Once I have figured out what my intensity is, the next thing for me to do is figure out how many pixels I want to be in the range. Now the 100% corresponds to all the pixels that are there, whether black or white, in this entire circular region of interest. So the number of pixels that will show up as green are very little comparatively, because the dark test is very little. So ideally what I do is select somewhere in the middle of that, and then you can now go in the live image and look at the results over here. If I rotate the can around within my fixed region of interest, it comes out to be the pass if I have the amount of text that I configured to have. However, if I now start blocking some of that text, now you start seeing a fail, because it doesn't see any darker pixels, because it only sees white bright pixels. As soon as I remove that back again, you get a pass. Other approach over here would be, what you could do is, instead of having a single pixel counter tool, you could insert multiple pixel counter tools covering the same region of interest. Then what you can have up to 32 detailed inspections, so you could cover the same region of interests with 32 pixel counters, and then you would have 32 results over here. So what that would do basically is you would have a bigger green bar, because the change detected now in each of those pixel counters would be greater, because you're looking at a smaller region of interest, and therefore if there is text in that smaller region of interest, the change detected would be bigger. Hopefully this gives you enough illustration of how to approach its application. If you have further questions, feel free to get back to us at 1-800-325-7425, followed by extension 2, followed by extension 4. Thank you.